just wanted to say hello. Eli really wants to help me teach this next lesson because he loves dividing decimals. But I told him that he's too cute and it would be too hard to concentrate. So instead, I'm letting him say hello. Say hi. Hi. Say have fun. Say I love math. Yay! We'll see you later. Say bye-bye. Do you want to run? Do you want to show him how you can run? Okay, pick up the football. Go get the football. And run! Woohoo! Touchdown! Say go Pack go! Yay! Noah, do you want to come say hi to my students?
Hi you guys, happy Tuesday. I thought I would have a little change of scenery, and so I'm coming to you live from my basement in the kids' play area. We've got a workshop, Legos, kitchen set, just about anything you can need. My computer's currently on the train table, so man, my kids are lucky, aren't they? And speaking of lucky, you guys, I don't know if you're having trouble with your goal or not, but talk about things to be grateful for. You had 3 teachers in the classroom yesterday, Miss Wolf, Mr. Novak, and Mrs. Hines. Oh my gosh, Mrs. Hines is so great. I wish that you had the good fortune of getting to spend time with her every single day because she's like a math goddess and someone who I very much admire and look up to. So anytime she is willing to grace us with her presence, I just very much appreciate. And she went out of her way to come and stop by to see how things were going. So I just thank you, Mrs. Hines. Thank you, Miss Wolf. Thank you, Mr. Novak, for taking such good care of you all while I was gone. Noah is on the mend. He's not 100% better. My husband Randy's staying home with him today, and so hopefully this icky virus will work its way out of his system soon. So anyway, I will have spoken with you by the time you're watching this, and so I will kind of have known, I will kind of know how things have gone, but today's lesson is dividing decimals. So I'm going to kind of bounce back and forth between my face and just the notes that you're going to need to take. And so if you would please get your pencil out, get your packet open and ready to go. This is lesson 02-07. This is kind of the big finale of our decimals unit. So we're looking at a test coming up here pretty soon. And again, this is review. I know that you've divided decimals before, but the part that's new is the fact that there's negatives and positives. And again, I would say that's the easiest part of this. So it's just getting a little refresher, reminder about how to divide decimals. Oh my gosh, look at that. Somebody already wrote, I love dividing decimals. Crazy. All right, here we go. So I want to make sure that this works. I hope you can see this screen. Unit 2, decimal operations. Divide positive and negative decimals. By the end of today, you will be able to divide positive and negative decimals. And I'm going to be honest, I don't know if your notes look like my notes. My computer died, so I'm using my husband's, and the only Unit 2 packet that I was able to access was this one, and it's a little bit different, and so I'm just crossing my fingers and hoping that it's similar enough where you guys can kind of fill in the gaps. If it's not, then just listen to me teach and we will get the notes filled in after this video. But if there are parts of it that are the same, go ahead and fill in these notes. Jot down questions if you have them. Do the brain breaks as I ask you to do them, and listen to everything because there may or may not be some hidden questions or trivia included in this video. So here we go. Dividing a decimal, and I broke it apart into 2 parts. Dividing a decimal number by a whole number, and then dividing a decimal number by another decimal number. So dividing a decimal number by a whole number is really similar to the whole number division you've done in the past. Here are a few differences to remember. there are not going to be any remainders. So I know when you've divided in the past, we get to this point where something doesn't fit perfectly, and so we just write a remainder. When there are decimal operations happening, you do not have remainders. You actually complete the problem as far as it can go so that your remainder turns into a decimal. Number 2, zeros can be used to extend decimal numbers in the dividend without changing the value of the quotient. So you can add zeros to the end of a number, however many zeros you need to, without changing the value of that number. Number 3, when your division is complete, a decimal point will need to be inserted into the quotient. And just a reminder, quotient is a fancy way of saying the answer to a division problem. An estimate will tell you where to put the decimal point. There will only be one reasonable location. So hopefully, if you're using that little think bubble like we did yesterday with multiplication, estimation will be pretty simple and you'll know right where to put the decimal point. So for example, 1.7 divided by 3. The trickiest part that I've noticed for many students is figuring out how to get your problem set up. And so this first example, I see lots of mistakes happen. I see kids putting this number on the outside, and that's not correct. So here's what I like to tell my students. First of all, if it helps you, rewrite it as a problem that looks like a fraction. 1.7 over, because this bar actually means to divide, over 3. So if it helps you, the first number goes on the top. That becomes our numerator. The second number, the number that we're dividing by, becomes our denominator. Once you've got it written like this, somebody once taught me this cool little trick that says, kick the dog out of the house. So dog represents the denominator. I don't know where they came up with this, but it's something that stuck in my head as a cool way to remember. So dog, the number that's on the bottom, when you write it like this as a fraction, denominator DD, okay, you get it? Kick the dog out of the house. So when we set up our problem and we draw our little house, the dog, the denominator, the number that's below, goes outside of the house. Kick the dog out of the house. So it goes on the outside of that little house. And then the numerator is the number that gets placed inside the house. So I don't know if that helps you or not, but truly, I feel like this is one of the hardest parts of division, especially when it comes to decimals, is just getting your problem set up correctly. So once we've got it set up correctly, there are some rules or some steps that we need to follow. So I'm going to bounce back to the notes here for a second. I don't know what happened. Sorry, it just went crazy. My computer just went crazy. So I'm back. And timeout. Thank you for not judging me for the way that my hair looks right now. Sometimes when you're a mom, you don't have time to take care of yourself. And so today, when I was recording this, I'm not going to lie, I haven't even showered today. So thanks for not being judgmental. And let's divide this decimal problem. Here we go. 1.7 divided by 3. So now that I've got my problem set up, it's okay if there are decimals on the inside of the house. We don't really care about that. When it's not okay is when there are decimals on the outside. But the good news is these first couple of examples, we're dividing by a whole number. And so 3 is on the outside, and so I can just get to work. I'm asking myself, and the thinking that I'm doing in my head is, does 3 go into 1? It doesn't, so I put a 0. Then I can scoot over. Does 3 go into 17? And it sure does. It doesn't go in there perfectly, but it goes in there a few times. So if I count by 3s or use a multiplication chart, 3, 6, 9, 12, 15, 18. Doesn't quite fit 6 times, but it goes in there 5 times. The amount of times that that number goes in, I place right above that 7. So 5 times 3, go ahead and multiply it out. My husband's creeping on me. 17 minus 15, the difference of that is 2. There's no other numbers to bring down, So I ask myself, does 3 go into 2? It does not. So what I need to do is add a 0. 1 0 I kind of get for free. Now I can ask again, does 3 go into 20? And it does. 3, 6, 9, 12, 15, 18, 21. Not quite 7 times, but it goes in there 6 times. Multiply. 6 times 3. I'm going to rewrite this up here. Is 18. Subtract to find the difference. 20 minus 18 is 2. Nothing else to bring down. 3 doesn't go into 2, so I add another 0, and I'm starting to notice that this is going to continue on. It's going to repeat because 3 still goes into 20 6 times. 6 times 3 is 18. Subtract, get 2, bring down the 0, and we're going to keep going on forever and ever and ever and ever. There's a better way to write that. This is a waste of ink. Once we realize that there's a number that's going to be repeating, we can actually use bar notation and just put this bar over the number that repeats. The 5 doesn't repeat, so we do not extend the bar over the 5, but the 6 is going to go on and on forever. And just as a quick reminder, this number, oh wait, we haven't figured out where the decimal point goes. I just bring it straight up, or you can use estimation. 1.7 is really close to 2. 2 divided by 3. Ooh, 3, that's going to be less than 1. So this answer has to be also less than 1. So this answer, just as a fun little throwback, is rational. Why? Because it's repeating, and any numbers that repeat as a decimal are considered rational. So there's example number 1. Most important thing, getting your problem set up correctly. I think it helps to rewrite this like a fraction. First number goes on top, second number goes on the bottom, and then I use that kick the dog out of the house to put the denominator on the outside when I set up my problem. Do what you do when you divide. Bring that decimal point up, or use estimation. And I actually know that 2 divided by 3 is the same as 2/3, which is 0.6 repeating. And so I feel pretty good about my answer being 0.56 repeating. Okay, example number 2. I don't remember what it is. 4.572 divided by 9. So I'm going to take the extra 5 seconds to rewrite it like a fraction. 4.572 divided by 9, or over 9. Okay, I rewrote it like this. This bar means to divide. So now that this is the denominator, this is the numerator, I'm going to kick the dog out of the house. Set up my house. The dog goes on the outside. The decimal number, or the numerator in this case, goes on the top, goes on the inside, and now we can divide. 9 does not go into 4, so I put a 0. 9 goes into 45. It sure does, and I love it when this happens. It goes in there evenly 5 times. 5 times 9 is 45. Subtract to find the difference. The difference is 0. We got a number next door that we need to bring down. Is this thing in the way for you guys? I don't know if it is. So we bring down 7. Does 9 go into 7? It doesn't. It goes in there 0 times, actually. So we bring this 2 down. And now does 0 go into 72, or does 9 go into 72? And it does. It goes in there perfectly 8 times. Now we need to figure out where the decimal point goes. If we estimate 4.5 divided by 9. Well, I know that 45 divided by 9. Well, you guys can't see that. That looks like 45 to you. I know that 45 divided by 9 is 5, but this is only 4.5. So my answer's got to be way less than 5. In fact, it has to be less than 1 because 4.5 divided by 9, 9 doesn't even go into 4.5 one time. So I'm thinking that I'm just going to scoot that decimal point straight up, and my answer is 0.508. What I love about division is that you can always go back and double check by using multiplication and sort of the reverse of what you just did to see if that answer is correct. So I could take 0.508 and multiply it by 9 to see if I get back to here. And I do, and I'm so happy. And if I just take that extra little time to check my precision and accuracy, I feel better about myself because I know that I'm doing it correctly. Okay, if we bounce back to the notes, first, I'm going to have you do a quick brain break. I know this seems weird, but I just want you to get up and moving and out of your seat. You don't need to make any noise because everybody's at a different place in this video. So go ahead and stand up on your chair carefully, smile at me or at somebody else. You could even give a thumbs up. Stretch your arms or legs if you need to, and then sit back down. Do not make a big deal out of this. Do not be a huge distraction. Please be safe. This is just to get you up and moving around. If you need to do a quick little wiggle or a quick little tree pose or whatever it is, do it. But this should take 1 minute or less, and then we're back to business. All right, dividing a decimal number by a decimal number. A few things that you need to fill in here for notes. When dividing a decimal number by a decimal number, many people create a new division problem that will have the same quotient, which means answer. This can be done by multiplying both the dividend and the divisor by the same amount. So the number on the inside of the house and the number on the outside of the house by the same amount or the same number. When creating a new problem like this, multiply by a power of 10. That will make the divisor a whole number. So this is kind of wordy and a little bit confusing. I think once you see an example, it's going to make more sense. But we're not going to multiply by any random number. We're just going to multiply by 10, 100, 1,000, which really just means we're going to move the decimal point. And this should come back to you when you see an example. So for example, it is true that 3/4 is the same as 30 over 40. What we did there is just multiplied by 1 power of 10. So if you multiply by 10 on top and 10 on the bottom, you get 30 over 40. I didn't change the value at all. Those two numbers are exactly the same. It's also true that I can change 0.3 over 0.4, times it by 10, or a power of 10, top and the bottom. And as long as I do that to both the numerator and the denominator, it doesn't change the overall value. 3/4 is the same as 30 over 40, which is the same as 300 over 400, etc. So the quotient or the answer of those problems are all the same. So there's a super easy way to create these equivalent problems. If there is a decimal point in the divisor, just move the decimal point in the divisor to the right until a whole number is created. Divisor is the same as the number that's on the bottom, the denominator, when we write it like a fraction. So if there's a decimal in that dog who's outside of the house, we've got to bloop it over or move the decimal point to the right as many times as we need to until that number is a whole number on the outside. To ensure that the quotient of the problem stays the same, we're going to move the decimal point on the inside of the problem, the dividend, the same number of spaces to the right. This is going to come back to you when you see an example. For example, 17/100ths divided by 3/10. 17/100ths divided by 3/10. 17/100ths divided by 3/10. See how I just did that right away? Now I can remember the bottom number is that denominator. I'm going to kick the dog out of the house, put the top number or the numerator on the inside, and my problem's set up. There's a problem. We don't have a whole number on the outside. And so here's what all those words that we just talked about actually means. If there is a decimal on the outside, you got to move it. Okay, we're going to multiply by a power of 10, which means we're just going to bloop this over one time, or as many times as we need to, so that there's a whole number on the outside. So if I move this over one spot, I get 3 point nothing, which is the same as just 3. 3 is a whole number, so I'm good to go. But because I blooped it over one time here, I need to bloop it over one time here. So I'm going to rewrite this problem. 0, 1, I don't really need that 0 in there. So I'm just going to rewrite it like this. So I haven't changed, I've changed the problem the way that it's written, but the quotient, the end result, is going to still remain the same. And this just makes my life easier now that I have a whole number on the outside. Because now I can divide like normal. I don't have to worry about where the decimal point goes because I figured that out in the end. 3, does it go into 1? Nope, it doesn't. Does it go into 17? It sure does. 5 times, this seems familiar. 5 times 3 is 15. Subtract to find the difference. The difference is 2. 3 does not go into 2, so I have to add a 0. 3 goes into 20 6 times. 6 times 3 is 18. You know the drill. This is going to keep happening. The 6 is going to end up repeating. Do you notice that this problem, the quotient, the answer is the same as the other problem? We just moved the decimal point, but we moved it the same amount in both the numerator and the denominator. So our answer, our quotient, is actually really the same. Decimal point, we just moved straight up. Both of our numbers are positive, so the answer to this problem is 56 or 0.56 repeating. That's kind of a tricky one to say, like a mathematician. I can't remember what I was going to say about that. So far, we have only been dealing with positives, and so we don't need to really check the sign. But that estimation bubble, again, I should have done that in the first place. 0.17 divided by 0.3. This is a little bit trickier to estimate, truly. I would probably have waited to estimate until I changed my problem, and then I would have done that same estimation. Well, 1.7 is really close to 2. 2 divided by 3, I know, is an equivalent to 0.6 repeating, and so my answer seems pretty close. Okay, so there's a lot to this, you guys. Dividing decimals is not super easy. It's not for, you're not going to be successful at it if you don't have the patience to make sure that you're really thinking through each step. So if you've already spaced out to this video and you have no idea what I'm talking about, you're going to need to rewind and you're going to need to focus, right? Because this is a lot of steps. So the biggest thing is making sure that you have a whole number on the outside of the house, which means you need to have a whole number in the denominator. And how we get a whole number is by blooping. I call it blooping. That's not the technical term. But multiplying by a power of 10 or by 10, by 100, however many times you need to bloop. And when you bloop on the outside, you have to bloop that same amount on the inside to make the problem or the quotient remain the same. Okay? Yep, just notice that those examples had the same answer. We talked about this. All right, I'm going to go back to one more example. Do you notice something about this example? You should. Hey, I forgot to tell you this, but you should be writing down these examples. The work that I'm doing, you should be copying them down because it's really helpful to be able to go back and look at a problem step by step. So if you need to rewind, go back, write down this work, you should do that. Okay, here's example number 2. 0.4572 divided by 0.9. I'm going to rewrite it like a fraction. And then I'm going to kick the dog out of the house. Here's my dog. Where my dog's at? That's an inside joke for the tsunami teachers. We're putting that on the outside. Numerator goes on the inside. My problem is not ready because there is a decimal on the outside. I don't care about the decimal on the inside, but if there is a decimal on the outside, it's not okay. So we need to multiply by a power of 10, which means bloop that over. Just one bloop will actually take care of this because now we have 9.0, which is the same as 9, and that's a whole number. Because we did that on the outside, we need to do it on the inside. I'm going to totally rewrite the problem because it's easier to see and it's more clear and it's more organized, and it took me 3 seconds. So you should do that. Don't take the easy way out. Take the time to do this. This is when we become more precise and more accurate. And now we divide. 9 doesn't go into 4, but it does go into 45 perfectly 5 times. 9 times 5 is 45. The difference is 0. Bring down the 7. Doesn't go in there. Bring down the 2. Goes in there 8 times. I know I'm going pretty fast, but this is an example that we already did. Figure out where the decimal point goes. I'm going straight up from here. My little estimation bubble when I rewrote the problem was 4.5 divided by 9. 4.5 over 9, well, that's really close to 1/2. Almost, that is exactly 1/2. And so my answer should be close to 1/2 or 0.5, and it is. And so I feel good about that. Read the directions. If it asks you to round to the nearest hundredth, well, then I would only have 2 numbers, so I would need to take this into consideration to round this number up or down. So you'll just have to follow directions in your homework for what it asks you to do or how it asks you to round. Quick brain break. Would you rather? Find a spot in your packet to write the answer to this question. Would you rather have lunch with someone famous or have lunch with someone who is no longer living? Now, the person who's no longer living could have been famous back in the day, but I want you to think about someone who's famous right now or someone who is no longer living. And more specifically, I want you to tell me who that person would be. It could be anyone. It could be a family member that's maybe passed away. It could be someone famous who you just have a huge crush on and you would die if you were able to have lunch with them. Anybody. Write it down somewhere. Put a little heart or a box or something around it so that I can see when I'm looking at your notes that you did this part of the lesson. One final thing. When we are thinking about whether the answer to a division problem is going to be positive or negative, we just got to remember those rules. Positive divided by a positive is always going to be a positive. Negative divided by a negative is always going to be a positive. A positive divided by a negative or a negative divided positive, negative divided by a positive, when there's one of each, your answer is negative. So use this little dude to help you check the final answer to make sure that it is accurate and precise. Don't forget that step. It's a really easy one to forget because you've just done a ton of work to get the answer, but make sure you finish it off to completion. Okay, we're going to do a couple more. If you feel comfortable and you feel like you're good to go, you're welcome to pause the video and start on your homework assignment. Your homework assignment is 02-07. And I believe there's a couple of extra puzzles, just like it's been in the last few assignments. The puzzles are optional. If you do them, great. You're going to be a step ahead of everybody. If you choose not to, that's your choice, but you have to complete the first assignment that's in your packet. So the example that I'm going to show you is negative 18.3 divided by 0.3. I just rewrite it right away like a fraction. Kick the dog out of the house. Goodbye. You're going on the outside. I'm just ignoring the negative sign right now, you guys. I'm going to come back to it. I promise you that I will, but for now I am ignoring it. There's a problem because there's a decimal on the outside. There can't be a decimal on the outside. Bloop. It's fun to make that noise if you want to. Bloop. Rewrite the problem. 3 is a whole number. I'm happy when there's a whole number. 183. And some people wonder, like, 183 point what? Well, really it's 0.0. We don't need to write that 0. If it makes you feel better, we can. But any whole number always has a decimal at the very end. So that's why we just don't ever see it written that way, because it's kind of just cumbersome to have that dot at the end. But for knowing where to put the decimal point in the answer, I'm going to put it there. 3 doesn't go into 1. 3 goes into 18 exactly 6 times. 6 times 3 is 18. Have you ever tried just smiling more while you're doing your homework, while you're doing your math? I think you should try it. Has anybody ever seen Elf? Smiling's my favorite. It really is. When you subtract, you get 0. Bring down the 3. 3 goes into 3 exactly 1 time. Oh my gosh, I love it when they're this simple and they just are done, because 3 times 1 is 3 and I have nothing more to do. Figure out where the decimal point goes in this case. Now, this number is weird, right? 061 point. What actually even is that number? Well, let me use estimation to help. The original problem was 18.3, negative 18.3 divided by 0.3. So if I had to estimate that, 18 divided by 0.3, that's a number that's less than 1. What's 18 divided by 1? Oh yeah, it's 18. So 18 divided by a number that's less than 1, like 0.3, that's really like thinking, how many of these little 0.3s or 30 centses go into 18? 30 cents, 30 cents, 30 cents, that's 90 cents. So 3 30 centses go into $1. How many go into $18? I know that's kind of a crazy way to think about it, but that's really what we're asking. And so there's going to be a lot of these that go into 18. So if I look at my answer, it's going to be more than 18. And so this number, 61061.0, this 0 doesn't matter, this 0 doesn't matter, and my answer is 61. And you can think about that. Would it make sense that 30 cents or 1/3, little 1/3 sections, how many of them go into 18? I'm going to draw this out, and it might be even more confusing to some of you, but just bear with me here. So here's one whole. If I break it into thirds, how many thirds fit into one whole? 3. If I have 18 of these, that's going to be a lot of thirds that fit into 18. So 61 doesn't seem that unreasonable. When you finish with your homework today, I want to see your work. There's no way that you can get answers to these kinds of questions without showing work. So I would recommend doing a separate sheet of paper, because being neat, organized, and having enough space to do your work is like the number one thing that I think is the most important. When you're finished and you can show me your work and you have your answers done, I would like you to come up and let me see, and then I'm going to actually have you check it with a calculator, because it's important for us to know how to do this. Oh my gosh, I didn't even finish this problem. Some of you are probably screaming, Mrs. Spring, that's wrong. Here's why. Negative 18.3 divided by a positive. A negative divided by a positive is a negative. Sorry, I forgot to do that super important part. Shame on me. Please don't make that same mistake. When you're done, come check with me. This has been a long video. I hope it's been entertaining, to say the least. It's late. I'm ready for bed. I will see you soon. If you have questions as you go, let me know. Otherwise, remind yourself that you have so much to be grateful for, and that this is an opportunity for you to learn and be better and have a wiser brain. Okay? And there are kids all over that would give anything to be in school and getting an education. So I know it doesn't always seem fun, but you get to be here. Remember that. Okay? And today is election day. So when you're 18 and you have the power to vote and you want to make changes in the world, then you can use your voice to do that. Like if you want to get rid of dividing decimals in 7th grade pre-algebra, then when you're 18 and it's election day, you can fight to make those kinds of changes happen. I hope that you don't fight to make that change happen, because decimals are really important in the real world, especially when we're talking about money. Okay, I'm blabbering. Have a good day. Bye. One last little message from Noah.
Dividing recipes. Dividing decimals. Yeah. Dividing decimals. Rules. Say have fun. Try your best. See you soon. Go Pack Go.